All right, thank you. Good morning, good afternoon, and good evening, everybody. So I'm going to be talking about teaching out of field and looking at it from a quantitative perspective in the state of Texas. And let's see. There we go. Okay, so a little bit about the American context. In 2001, we had federal legislation that essentially outlawed teaching out of field. Teachers had to be certified in the subject that they were teaching. They were called highly qualified teachers, and that within the first 3 or 4 years, I can't remember exactly, that 100% of teachers who were hired had to be highly qualified, meaning teaching in field, and then the rest of the teachers had to get certified so that they were teaching in field. But in 2015, the federal legislation changed and that it eliminated the highly qualified requirement. It essentially legalized teaching out of field. So since 2015, it has been legal in the United States to teach out of field, but the way the legislation was written, it had to be, the distribution of out of field teaching had to be equitable among the different student groups. So white and non-white students, poor and wealthy students, urban and rural students, all of those had to have an equal percentage had to be taught out of field. So I did a study with Amy Piot, a colleague of mine, and we were looking at teaching out of field in the state of Texas, looking at millions of students, because there's 5.5 million students enrolled in each year in the public education system here. And what we found was that after the federal legislation changed and legalized teaching out of field, we saw a dramatic and significant increase. And the rate of increase has been increasing over the years. We've done a subsequent analysis beyond this published study with additional years of data, and the rate just keeps increasing of the number of classes that are being taught out of field. We also found that the distribution of the out of field taking of classes was not equitable. So even though the federal legislation required that white students and students of color were taking equal percentage of classes, that was not happening. We also saw a difference between male and female students. Students in rural communities were taking more classes out of field than suburban communities. But what a lot of studies have shown is that urban students take higher rates of out of field classes. We didn't see that. Students from low-income families were taking more classes out of field than wealthier students receiving special ed services. So it's clear that what's happening in Texas as a result of the changes in federal legislation is that students are not taking classes out of field equitably. There's large differences across the different student groups. So why does this inequity matter? Why should we care from the student perspective? Well, there's a number of studies that exist that look at teaching out of field and student growth. So student academic growth, not height. And we're looking at teaching out of field is associated with lower academic growth in the studies that have been published. But most of those studies have used national assessments, national exams, or international exams. So in the United States, we have the NAEP, which is an assessment that is done by samples of students across the different states to look at performance. The interesting thing about that is the exams are not aligned with the curriculum that's being taught in those classes. So we're talking about the impact of teaching out of field, but the test and what's being taught in the classes are not in alignment. Okay, so we wanted to look at it from the perspective of what happens when the exams are aligned with the curriculum. So there's one study that we found that was a quantitative study that looked at data in the from a value-added modeling standpoint, looking at student academic growth. and it used the entire data from the entire state of North Carolina. So in that case, the exams were linked with the material that was being taught by the teachers. So this is a good thing. So what they found was that the secondary students scored significantly higher when the classes were taught in field. But the comparison group in this case was compared not against out-of-field teaching, but uncertified teachers. So this doesn't help us to do they didn't do a direct comparison of in-field teaching against out-of-field teaching. So we wanted to look at this in the state of Texas and look at that issue. So the question, our research question is, do students taught in field perform equally well on the state end of course exams as students taught out of field, after accounting for differences among students, among teachers, and among their schools? Okay. So the data we have access to is an enormous resource. We have a P20 workforce state longitudinal data system, or SLDS. What that means is essentially we can track a student from pre-kindergarten through graduation from high school, entry into college, graduation from college, entry into graduate school, graduation from graduate school, and working in the workforce. So we can track somebody from entry into public school to retirement if they live in our state the entire time. Okay, we can't know who they are. All of the identifying information like their name, date of birth are removed, but we have special IDs that allow us to link people across time. So we have enrollment data, services that they receive, what grades they're in, how they do on state assessments, whether they're receiving special ed services, whether they're receiving language services, things like that. The data set that I started with for this study contained 235 million student records that were linked to the specific classes that the students were taking, and it had records of who the teachers were for each one of those classes. So we can know, without knowing the names, that Mrs. Jones is teaching Algebra 1 third period on Monday, Wednesday, Friday, and who the students are that she was teaching. Okay, so we can narrow it down to that granular level. And this is only for secondary students. The whole file is a 500 million records. And it's from 2011 through 2019 is the data that we're looking at. So in order to make this a little more manageable, I selected math in grades 7 and 8, Algebra 1, English 1, and English 2. So these are all secondary exams where the exams happen at the end of the semester, and the exams and the courses are directly in alignment. The state says, teachers, you must teach the curriculum, and then the tests are a test of how well they implemented that curriculum. Okay, so we also have very detailed rules in Texas about what constitutes infield versus outfield. So a teacher can have multiple certifications. They can take exams and get certified in different subjects by showing their expertise. And we have very specific rules that if you're going to teach an Algebra 1 class, you have to have one of these specific certifications. And those are the only certifications that mean that you're teaching in field. So using those rules, I determined for every course whether or not the teacher was certified to teach that course. And then what I did is I'm going to do 3-level hierarchical linear modeling with the data. The students are at level 1, teachers are at level 2, and schools are at level 3. And the data are strictly nested, which means that the teacher is only associated with one school and students are only associated with one teacher. So this is the sample size to give you a sense of the kinds of data that I'm working with here. So for the English 1 analyses that I'm doing, I have just under 1.7 million unique students and all of the demographic information, services, state assessments, all of that. So you can see Algebra 1, we've got just under 1.8 million unique students and all of their data. And then because this is a hierarchical linear modeling, HLM analysis, the clustering of the data is really important. We have to make sure that we have enough teachers represented and enough schools represented. So here's an example of the Algebra 1. We've got 1.8 million students coming from 20,554 different teachers in 3,800 different schools. So we've got plenty of data to work with for an HLM analysis. So I ran a series of analyses for each of the different subjects. The outcome is the end of course exam score, and I z-score transformed it so it was based on the average of all the students who took it at that time. Excuse me. Model 0 is the unconditional model, which I'll explain in a minute. Model 1 is we add the student variables, the student predictors. Model 2, we then add additional teacher variables, and then Model 3, we add school variables. And so the first question with the unconditional model is HLM warranted? What we do is we put just the outcome variable and no predictors, and we look at the variance that's explained. The short answer is yes, there's a substantial amount of variance that's being accounted for at the level 2 and level 3. Here's an example for Algebra 1, 40% of the variance is at the school level and 11% is at the teacher level. And English 2, it reverses. I understand why the school level at Algebra 1 is so large. We don't need to get into that right now, but it makes sense. So there's a substantial amount of variance that's happening at the level above the student. So HLM is warranted in this case. The student variables were the prior year's exam scores. So if they took Algebra 1, then we looked at the prior year math score. If they took English 1, then it was the prior year English reading exam. We looked at student gender, ethnicity, income status, English language learner, special ed, and also students can take Algebra 1 in grade 8 or grade 9. So I had a variable for that. Adding these variables to the model were highly significant. So they explain a lot of the variance. From the teacher level, the variables were teaching experience, and then the level of academic degree that they held. So whether they had a bachelor's, master's, or doctorate, and then teaching out of field was the variable of key interest here for this study. For the school variables, we had school locale, so whether it was rural, urban, suburban, and then we have public charter schools in the state of Texas, so we had a flag for whether or not it was a public charter school. Here's the key result from this is that there was the teaching out of field was a strong negative predictor, that scores on the state exam were substantially lower when the students were taught out of field compared to students taught in field. And here's the magnitude of the effect. So you can see that for English 1, it's 17% of a standard deviation. These are huge effects of teaching out of field. I'm surprised by the grade 7 that it's so small, but it's still highly significant. But you can see that the certification, the teacher being certified to teach the subject really does matter to these students. There are dramatic impacts, negative impacts of taking a class where the teacher is taught out of field. To give you a sense of the magnitude, the size of the effect of teaching out of field is 3 times greater than the effect of student poverty. Which I was blown away how big the effect is. It's larger than all of the teacher and school variables, so it has a greater impact than teaching experience does. It's a greater impact than advanced degrees, the urban, rural, suburban characteristics. So this is one of the biggest effects that I found in the modeling. So the implications are that students are harmed academically by taking classes that are taught out of field. This is a substantial, significant negative impact. And in Texas, the initial certification is done through a preparation program, but then additional certifications are permitted through testing and preparation without having to go through a formal program. So that content-specific certification does matter. And taking together the results from our earlier study, that's the student harm that's happening as a result of teaching on a field is it's not equitable, because students of color are more likely to take out of field classes, therefore they're more likely to be hurt by that fact. And it also shows that in the US, the federal policies have an important influence on the local teacher assignment. So if the federal laws say you can do whatever, the schools can do whatever they want to assign teachers, then they take them up on it, and they actually start to put more teachers in there. And that has a negative impact on the students. All right, thank you.
Wow.
Questions? So I see Marcel has a question about the social studies, geography, and history. We have data for the end of course exam in American history. We have not yet analyzed it. So we will be looking at whether the same effect happens in history using the end of course exam. We also have biology. Biology end of course exam data, so we'll also be looking at those in the near future.